right. Hello, all of you. There's quite a many of you. Thank you, thank you. What a pleasant view over here. I was actually expecting that there's most likely you guys are enjoying some beers and so on. So I was expecting that some of my friends may be joining, so this is excellent. All right, but first of all, I have been once again enjoying this event quite a lot, so let's start with uploading for all the organizers, including video and audio guys behind the scenes. So. Such a great event. All right, so my name is Mikko Kenttälä. I'm one of the founders and CEO of SensorFu, but I'm over here talking a bit about my Happy Hacker hacking projects. I do vulnerability research every now and then as a hobby, and this is more related to that. And if you want to follow me in some of the social media platforms, you can find some handles from there and so on. But let's dive in to today's topic. So, in previous episode last year, I presented zero-click vulnerability related to Apple's macOS calendar. During that time, I've already found whole chain of vulnerabilities in a way that I could be able to exploit the vulnerability in a way that I get access to the sensitive data of the user. But since many of those vulnerabilities was still unfixed during that time, I couldn't do the whole presentation related to the vulnerability chain. So I do quick recap about what happened in the previous episode, and then we dive into the details that how one can leverage and exploit this kind of vulnerability, what I found from calendar. How many of you need to use calendar for daily basis for your work use or personal use? So quite a many, almost everyone. Congrats for those who don't need to use it, but let's dive in. So, calendar itself and the services behind the calendar services are rather old. There's basically two different branches, one which is done by Microsoft. It's working a little bit differently, and then there's Calda, which is basically what everybody else seems to be using. It's a rather old protocol, has been working since when it was introduced 2007, and it's based basically the web server or the calendar service side is based on the rather well-known and well-adopted and old specification related to the WebDAV. Rather simple idea. Most likely all of you know the basic functionality. If you have multiple devices, you connect to the calendar server and those events will be synchronized. This is how it looks like under the hood. So one event, if you have a calendar event, it looks something like this. You don't need to keep eye on all the details, but you get some sort of idea. It's plain text protocol. There's an organizer. There's an attendee, email addresses, and so on. So you typically, when you are exchanging calendar invitation or adding something to your own calendar, it includes information like this. These are event information. Calendar events have also nice features like you can add links to the video meetings and sometimes geolocations and maybe attachments, for example, as in this example, like a memo.txt. These basically will be transferred also for the third parties. So if you invite someone to your event and you add an attachment to the calendar event, it will be also propagated to the other participant to that event. Under the hood, the attachment look like something like this. So there's an attachment section, nothing specific, file name included, and so on. I think you guys get the idea. For example, for the attachment, it can be in iCloud, stored in iCloud. So in that sense, it's a URL. which is pointing to the actual document, or it can be encoded with base64 as part of the calendar event itself. So, vulnerability related to this was this. So, rather simple, familiar vulnerability type from the late 90s or something like that. So, really common mistakes seen over the years. But for some reason, this still existed in the calendar back then. So basically what I did, that I can send you a calendar event which includes base64 encoded data and a pointer for the file name, which is pointing to the different directory. So typically this would be just a name like a poc.txt, but in this case there was a pointer tree dot slash basically pointing downwards in your hierarchy of files. So this would be end up to your file system this way, that it's in macOS, all the files will be stored under the library, calendar and calendar ID and so on. It should be stored over there, but since there's those dot slash things, it will be actually stored to the completely different folder than intended. So this was the arbitrary file write vulnerability. Then there was also arbitrary file delete capability with this same type of vulnerability, or you can trigger it with the same way, almost same way. So if you try to store file which already existed in the system, it actually won't be overwritten. It will be renamed in a way that it will be stored this way, that there's -1 after the actual name, if only this calendar cache actually existed on the file system already. However, if later on I've sent the calendar attachment to the victim, and if I remove the attachments later on and update the calendar event in that way, that attachment will be removed, even though the file was stored this way, the original file will be deleted. So there was a logic error in the code in that sense, and that basically happened. All right, but this was basically what I presented in last year's presentation, and with this, what I was able to do is that I can send basically calendar invitation to any iCloud user in a way that they didn't need to do anything. It will just pop up on their calendar. It will include my attachment, which could be malicious, and it will be stored to your computer, your disk, and you basically don't have much chance to do anything. So basically, Tim Cook at iCloud.com would work in that sense. All right, but let's dive into the details related to what you can do with that, because these things are the ones what I couldn't be able to talk last year. So in episode 2, we discussed more about how to escape from the sandbox and gaining the code execution right, and then later on also getting access to your sensitive data. There will be some, don't worry if you cannot fully follow all the steps. It's rather confusing. When I was doing this presentation, I had a hard time to follow that, how this chain actually goes and works, but I will summarize it at the end of the presentation. But there's many obstacles. I will first go through the obstacles and how to attack against those obstacles. And at the end of the presentation, I will summarize how the whole chain actually worked. All right, so the first obstacle, that when we had the file write access, it was inside of the calendar application sandbox. So basically, I was able to delete some files and add new files to these directories, but that's it. So what I can do from here? Obviously, it may seem that there's not much to do, but if we look these, we can already see that well, maybe we can somehow affect some of the features related to the calendar application, since we can write into the folders where all the data is stored, and there's some application support, address book, and sync services. Maybe I can find some vulnerabilities from there, or find some good, nice hidden features from there. So typically, since I enjoy a lot about logic bugs, I try to find out some nice features what I can leverage related to these exploit chains. So what I did was that I used that vulnerability in the calendar to inject new files. I injected new calendar to the file system. And because, well, that's at least something what the calendar application will handle. And there's some nice features with some of the calendars. I will cover that later. But I injected hacked calendar into the victim's file system. And in that way, there's a new calendar appearing to the file system. However, calendar application won't automatically add those calendars to your calendar application. Only in the few circumstances it will do a refresh and check that what's new on the file system and do the indexing or add those to your calendar. So then I was in the trouble that how now I have these files, which is legit calendar on the victim systems, but how one can actually trigger the indexing because it didn't automatically go there. But I found a way, and it turned out that if you add this file, it doesn't need to include anything, it just needs to exist on the file system, that if you have a calendar truth file migration progress on your file system, then next time when you open your calendar application again, it will see or check this file, and if it exists, it will do the re-indexing of all the files and convert that old legacy format from the file system to the SQLite database after that. So now I was able to get the calendar automatically added to your application. But so what? Now there's a new calendar which can be seen on the left bottom. So it's basically overriding the existing Siri suggestions calendar, and basically it looks like this. But so what? The reason why I wanted to do that is that the local calendars actually have more features than remote calendars. Local calendars have cool features related to the alerting that you can do. This is from Apple's instructions, that you can do message with sound or send an email when the alert happens or open the files. So I was thinking of that there's much more room to do something new with this functionality. Maybe I can get my malicious application in and get it that open, since there's the open feature and so on. And these features are only available at the locally stored calendars. There has been some vulnerabilities. 2004, for example, there has been issues related to the alerts in MacOS calendar. Back then it was called iCal. So it's a common challenge or problem that there may be things what you don't want to automatically appear to you. Or you don't want to have a calendar invitation which includes alerts which will send automatically emails or open some files or something like that. But since this was only limited to the local version, and as an attacker I had a possibility to add new local calendars, this seems something quite handy to research further. But then there's yet another obstacle. It's a gatekeeper. So even though I get something opened, if I send my malicious application and try to open that, it will be prevented by Gatekeeper, because it shouldn't allow any malicious kind of or unknown or not yet accepted application to run without your specific permission, or sometimes even if you try to add that permission, it may be that it's not possible. So we need to evade the gatekeeper. So there was yet another obstacle. The thing which was the biggest problem at the beginning related to the gatekeeper is functionality called guarantee function. So everything when calendar adds files which are coming outside of the local computer, or if calendar is adding something, it adds also guarantee flag that the gatekeeper will know that if something tries to run related to that file, it will trigger and say that, hey, by the way, this is actually downloaded from the external source, which came from the calendar, so do you really, really want to do it? So we need to try to evade the guarantee restriction. And I did it in the following way. And I created an image, disk image, what I injected with the feature from the calendar file write vulnerability. So that image already existed in the victim's file system. Then I used the alert to open that image. That disk image included or will be opened with the Finder. You can see it on the right side of the picture. And it included empty folder with the background image, including POC. And in reality, what happened under the hood, there was that image is not stored in that disk image which was mounted. It's actually stored in an external Samba mount, which was my Samba mount. So there was only pointer in that disk image in a DSTOR file over there in a bookmark format. That whenever your Finder opens that view, what you can see over there, it reads the storage and figure out that, oh, there's a background related to this. I will show that, and that background is stored over here. Oh, it seems to be a Samba mount. Okay, I will just mount it because the username was included. It will automatically mount it, and that way, all of a sudden you get on the maybe see it on the right or left corner. You can see it over here that there's also third or second mount existing. All right. Then we injected another file, which was URL file, which was basically pointing to new Samba mount, which was previously mounted. So you can see the path for that is volumes and calpoc payload, that my MIDI test app. Don't get confused with the MIDI, because MIDI application in macOS is the smallest application what I was able to find, so I weaponized that for these purposes. So the MIDI, the name is not that it doesn't sound that malicious. But basically what happens is that the Finder after that, with the calendar alert once again, will open next folder, and this folder is in the Samba mount. And what will happen automatically is that when this folder is opened in macOS, these files will be automatically indexed in a way that your macOS knows that there's this and that kind of files. And since it will find out that there's some cool new application over there, it will do a registration. This application actually includes this new URL scheme, basically URL handler, that after this indexing, there's a new URL in your operating system called my MIDI test. And after that, I am able to launch the malware, launching a new URL once again from the path my MIDI test // And since this application now is actually, it exists on the Samba mount, which was automatically mounted without the guarantee flag. So there's no guarantee flag related to this new malicious application, and the gatekeeper is looking at that. Okay, looks completely normal. There's no no guarantee flag related to this application. So let's run it. And then the malicious application, now I am able to run malicious application, so I have a code execution in the victim system this way, but I'm still somewhat limited because MacOS has other restrictions. But the malicious application, will do some preparation for that one. And we enter to new and last phase of my vulnerability chain. So now we have a code execution, but how to get access to sensitive data on the operating system. In macOS, sensitive data is protected by a solution called TCC. It is the pain as an obstacle, but luckily there has been many tricky ways to fool it. And I found maybe one way not to fool the TCC exactly, but to get hands on those files which are protected by the TCC. But whenever you are using your iPhone or macOS and you see this kind of pop-up that some application want to access to some files to your someplace or want to have an access to your microphone or whatnot, it's TCC. So that's the same, that's the application which is controlling the access to certain capabilities, which are typically related to the sensitive data, like a location or desktop files or whatnot. So, how to overcome this obstacle? Turned out that this was actually rather straightforward. I've been thinking of for quite a long time that I should play around with the functionality related to the application configuration. So I decided to take that road and see that what's waiting me in that realm. So I started to look how the photos was configured, because photos is rather sensitive content for many of us, including myself. So let's see how this actually works. So basically what I did, I just changed the configuration of the photos. I did it in a way that I did the changes for the configuration that in this exploit chain, the malicious configuration for the photos was imported from the var temp, and which was written by me via that vulnerability, what we discussed earlier. And basically what it does, it only changes some paths which are in use in the photos in a way that instead of photos is normally storing the photos on your home directory, and there's pictures, and under that folder there's all the photos. So I just changed the path in a way that it will be something different, and I make sure that the iCloud sync is enabled. I add a new photo library, which is empty, so it's like a template kind of photo library, and from the command line, since I had the code execution, I opened the new empty photos library from var temp, and since the configuration was already changed, it matched really well with this new photos library, and the photos will be running in a way that you now have malicious configuration in and template photos library, which is kind of valid, so it doesn't cause any errors. But when you open your photos, it sees that the iCloud sync is enabled, and it will start to automatically download all of your iCloud photos to the path which was configured by me to some completely different folder than which was protected by the TCC. So TCC was still protecting the original path really well and working smoothly, but I just changed the path for the pictures, and now all of those will be downloaded over there. So after all, rather simple trick, and but it worked. So now let's recap that what actually happened over there. I hope you have still some oxygen left over there, but and it may help. But first, we had an arbitrary file write vulnerability. Then we injected malicious calendar. After that, we injected the calendar truth file migration process to actually trigger your calendar application to actually activate the new calendar. After that, we injected the disk image, which included the background image, which will trigger the Samba mount. And we had the alert in the malicious calendar, which will later on open the disk image. And when the disk image is opened, now we have a Finder opened with that Samba mount. And when that's opened, launchd, which is running on the background, will automatically index our malicious application inside of that Samba mount. And in the fourth phase, we will trigger the new custom URL handler to open the malicious application. And now we have a malicious application running. And it will run my malicious code, which will change the photos application configuration. And then we launch the photos, and all the photos will be downloaded to my evil directory, which is controlled completely by me. And we are there. But thank you. And as you can see, it gets a little bit tricky because of these mitigations. But what I did basically is that all of these are rather straightforward logic errors and nice hidden features or something like that. But so it was basically, from the research point of view, I just did quite a lot of reverse engineering that how these things actually work and tried to figure out if there's some ways to get nice new features or do the next hop and evade some things and so on. I used some of the tricks with what I used before, however, in a different kind of places, like triggering the Samba mount. It's something similar to what I've done before, but I just kind of had a different place where to actually trigger it, which was a new way in the sense that it was not fixed, and so on. So, yeah, but we got there. If we take a look to the timeline, you can see that it is actually quite long. So there's quite a lot of going on, plenty of discussions going on with the Apple and so on. So as you can see, the original calendar vulnerability was already found at the late half of the 2002. I reported, then we had a kind of argument with the Apple that they were saying that no, there's no need for CVE for this because it doesn't seem to be too bad. Because at that phase, I just said that there's arbitrary file write and delete, which should be enough for CVE, but they said that there was some misunderstanding and they later on fixed it. But I got kind of like, I did the report. I was really busy with my work life and everything during that time, so I didn't immediately push it forward from the research point of view. When I found it, I kind of was in a situation that I needed to make my mind that do I push this further all the way to get the access to the sensitive data, because that's what Apple has been saying on the reporting guideline, that try to have as big impact as possible. But since I was so busy and I didn't do that, I just reported immediately. It was a little bit risky from the bounty point of view because the impact is not that big maybe in that phase, but it was like I didn't want to have a zero-click vulnerability on my table and knowing that it's existing and affecting millions of people and I'm not reporting it. So I just reported it. Anyway, then I got annoyed a bit about the fact that they said that there's no CVE, and I said that, well, I'm pretty sure that I can rather quickly do another POC where I can demonstrate that there should be CVE, and then I did the code execution, Gatekeeper, evasion, then later on provided the POC for the iCloud photos. It was the end of the year of 2022. Then they did they did the credit related to the calendar. The bounty state is still unknown, so let's see if I get it. Then the Gatekeeper evasion got fixed, but they didn't release CVE. Then I asked around that what's going on, and then they added the CVE to the photos vulnerability, which was different, and that was good. And then they announced that I will get the bounty, which was related to the photos and Gatekeeper. And then at the end of last year, I asked at what's going on with the CVE related to the Gatekeeper, because it's fixed and but it's not credited, and then they added the credits at the end of the year of 2023. So it may took some time to actually make it happen, but I think my time is up, and hopefully you enjoyed. Thank you.